And welcome back, students. Today we're going to start our lessons in understanding differences in file size. Let's talk first by discussing bit versus byte. Now, we have kind of talked about bit and byte before, right? But let's look at in regards to these two terms here. If you notice, they're very similar. We have MB and MB. But you can probably look at them and see that there is a distinct difference between the two. One has an uppercase B, one has a lowercase b. You're probably like, what's the difference? Well, there's actually quite a significant difference between M with a capital B and M with a lowercase. The one with the uppercase B is megabyte, the one with the lowercase is megabit. And if you recall, that could make a difference here because a byte is 8 bits. So if a megabyte is, if a byte is 8 bits, a megabyte has to be 8 megabits. So a megabyte is bigger than a megabit. Therefore, when you're saying you have something that's, for example, you have something that says, well, we're going to give you a package that's 8 megabits per second. What it really means is that you're getting 1 megabit per second. Right? Now, this is often seen a lot in marketing practices for things such as internet speech. Computer data transfers will often still be given to you in megabytes, whereas your ISP will give you a package that is in megabits. So just to kind of give you some examples, let's take a look at a couple of these and see what that actually looks like. So for example, let's say you get an internet package and they're going to give you 100 megabits per second download speed. That sounds awesome. All right, 100, I like that. It sounds really, really fast. But what does that actually mean? Well, that means you're actually getting about 12.5 megabytes per second. Now, if they came and said you're getting, let's say, 100 megabytes per second, well, that's a big difference, because a megabyte is very different from a megabit. Right. Similarly, inside your computer, a lot of stuff is done through data transfers. One of the most common data transfers is through SATA cables. A SATA cable has a data transfer rate of, let's say, about 6 gigs. If you were to take that full capacity, and usually they don't run that high, but if you take the full capacity 6 gigabits per second, it's actually only about 0.75 gigabytes per second, or only 750 megabytes per second. So you can see it's not quite as powerful looking once you actually start putting this into terms of bytes instead of terms of bits, which is funny because a lot of what we look at, like if you take a file and copy it from one location to another on your computer is not going to do it in bits, it's going to do it in bytes. And so that might be the reason why, like, wait a minute, 100 megabits, that seems really fast, but it's really still kind of slow. And it's because of the difference between bits and bytes. And that concludes this lesson, folks. We're going to continue working on this through our following lessons. So I will see you next time.